Welcome to Brain Vision.
So in this problem, we want to find the surface area where two cylinders are intersected. So to do this, we want to figure out the plane at which the cylinders intersect, and it's determined that the planes are x equals y and x equals negative y. So with that, we want to find the surface area of the cylinder x squared plus z squared equals 1 above the xy plane, wedged by the planes x equals plus or minus y in the first quadrant. So the total area will be 8 times this area because that's just the first octant. So what we'll use is the formula to find surface area. So we'll take the double integral of the square root of 1 plus the partial derivative of z with respect to y squared plus the partial derivative of z with respect to x squared. Okay. With all this, we can now plug in our values. So we know that the surface is z equals 1 minus x squared. So that right there tells us that z dy is just going to be 0. And then dz dx will be, this will be a negative x over z. So that'll ultimately give us a positive x squared over z squared. And that'll get rid of all this. This is x squared over z squared dA. We can combine these to give us, once we combine these, we can get z squared as a common denominator, and then we'll get x squared plus z squared, which we know to equal 1. So what we'll ultimately end up getting is the double integral of 1 over the square root of 1 minus x squared. Then we know that our bounds are going to be negative x to x here, and then the bounds here will be from 0 to 1. And then for dA, it'll be dy dx. And this is going to ultimately equal 2. It looks like it's slightly not 2, but that's just due to rounding. It in fact is equal to 2. So since it's equal to 2, we know that the total area, like we said, is times 8 of that. So that means we get 16 as the surface area of this.